To the second page. In this example, we're given a triangle that has sides 5, 12, and 13, and we're asked which trig ratio of the six do you think would be the largest. And so sine is opposite of hypotenuse, so let's label the sides over here. In the diagram, we're talking about angle beta now, or B, sorry. So angle B, for angle B, this would be the adjacent side, the 5 would be the opposite, and the 13 would be the hypotenuse. And that's because we're talking about angle B. If we're talking about angle A, hypotenuse would stay the same, but the adjacent and opposite would switch. So, to find the sine of angle B, it's the 5 side divided by the 13, so 5/13. And we might want to change these to decimals to actually compare all these. 5 divided by 13 is 0.3846 to 4 decimal places. For the cosine, cosine is adjacent over hypotenuse, so the 12 divided by the 13, which is just under 1, 0.9231. Tan is opposite over adjacent, so we'd be dividing the 5 by the 12, which is 0.4167. Cosecant is the reciprocal of sine, so sine is opposite over hypotenuse, 5 over 13, so this would be 13 over 5, which works out to 2.6. Secant is hypotenuse over adjacent, so we would go 13 over 5. Oh, sorry, not 5, 13 over 12, which is 1.0833. And cotan is adjacent over opposite, so it would be 12 divided by 5, which is 2.4. So this ratio is the largest. Also, if you want the largest ratio, really what you want then is the longest side divided by the shortest side, and that ends up being actually cosecant. Okay, so cosecant is the largest of all the ratios. One more example on the last page here. We're asked to solve the following triangle, and that means to find all unknown sides and angles. We know two sides being here, so we need to find this side and then angle B and angle A. We do know that angle C is 90. Now, we don't need any trig ratios to find this side here, okay, because actually we could use some, but we're going to use Pythagoras Theorem to start with that. Let's do a little labeling first, though. In triangles, we normally use capital letters for the angles. Now, if this is angle A, the side opposite is labeled with a lowercase a. This is angle B here, so the 4-kilometer side would be side B, lowercase b, and this is angle C, so we'll call the hypotenuse little c, lowercase c for the hypotenuse. So you label sides opposite angles with a lowercase counterpart to the letter. Now, Pythagoras' theorem says that c squared should equal a squared plus b squared. And so I want to solve for c, so I'll take the square root of both sides, so c would be the root of a squared plus b squared. Now, a is 10, b is 4, so we substitute those in. 10 squared is 100, plus 16 would be 116. So c is the root of 116. And so we take the square root of 116 and get 10.8 kilometers. So that's how long the hypotenuse side is, 10.8 kilometers. Now I need to find one of these two angles. And so I'm going to label sides. So I'm going to find angle A here. So this would be the opposite side, and this would be the adjacent. And then this would be the hypotenuse. Now, I do know all three sides. I found this one's 10.8, so I actually could use any of those 6 trig ratios to find angle A or angle B because I know all of the sides. So it really doesn't matter which one you pick. The one I'm going to use, though, is the tan ratio. I'm going to find angle A. Tan is opposite over adjacent, and I know opposite's 10, adjacent's 4. So I fill in the 10 and 4 in place of opposite and adjacent. 10 divided by 4 is 2.5. Now, the angle is the unknown. We do know what the tan ratio is. It's 2.5. So the way you find the angle is it's called the inverse tan. It's kind of taking the, you know what the tan ratio is, you're trying to find the angle whose tan is 2.5. And what that looks like in the calculator is this. You go second tan, the 2.5, okay, see the second tan right here, And that tells me the angle is 68 degrees. We'll just round to the nearest degree. You also could use the table here. The tan of the angle is 2.5. If you wanted to use the tangle, you're looking for a tan that's 2.5. See, these are really small. Okay, so too small. It only goes to 1 here. So we'd actually have to come over here on the other page. And we're looking for the tan is 2.5. Notice they're getting larger here. Larger here. 2.5. That's 2.4751 is the number closest to 2.5. And so again, that's 68 degrees. So you could read that from the table. Let's go back to the PowerPoint. So we take the inverse tan of 2.5 and get 68 degrees. Now, I want to show you alternate solutions. I'm not just going to show you the tan here. So another way that we could find that an angle is 68 degrees, we could use one of the reciprocal trig ratios. And so I could use cosecant. Cosecant involves hypotenuse, which we know is 10.8, and the opposite side, which is the 10. So I could substitute 10.8 and 10 in place of hypotenuse and opposite, and that divides out to 1.08. Now my calculator, I can't do this directly, but what I could do is go back to the table here. Now we're looking for a cosecant who the angle, cosecant of that angle is 1.08. So in my table here, cosecant, now I want to find a number that's closest to 1.08 here. Notice that these are really big. It's really no point in looking in that column because 1.41 is still too big. We want 1.08. So I will go up to the next column here, 1.08. See, we're getting closer here. Okay. Now that's kind of close, but notice that it's 0.086, 1.0785. That one is a little closer to 1.08. And so if we follow it over, again, we get 68 degrees. Okay, so we could use that chart to get the 68 degrees. Now we just put my stuff back up here. So using the chart, the inverse cos of 1.08 is 68 degrees. Now, there is one other way to do this rather than using the chart. And the fact that cosecant, if you remember from the first page, is the reciprocal of sine. So if the cosecant of this unknown angle is 1.08, you could evaluate that using your calculator. The reciprocal of cosecant is sine. So since it's a reciprocal, the sine of the angle should be 1 over 1.08, or the reciprocal of 1.08. So I would change this to a decimal, and then I would take my calculator and find the inverse sine of 0.9259. And again, the calculator would tell you it's 68 degrees. So I would perform this calculation exactly the same way I do this one, except I'm using sine, of course. Now, whichever way you do this, we now know that this is 68 degrees here. The easiest way to find angle B probably is the fact that if that's 90, then these two angles add to 90. And so angle B is just 90 minus the 68. So angle B is 22 degrees. And that's the end of the lesson.